dive into today's topic, please, if you've not already done that, please click on the subscribe button for more videos on chemistry. So today we'll be teaching nature of matter, the subdivision of matter. So matter is subdivided into two, the pure substances and the impure substances. The pure substances are the elements and compounds. While the impure substances are the mixtures. Okay, so today we'll be concentrating more on elements. Okay, but let's dive into the pure substances. The pure substances are substances that have the following properties. One, their constituents are definite, like their constituents are definite. Two is that they are homogeneous, meaning they are the same throughout. Three is that they have unique physical properties. And four is that they cannot be broken down or separated into simpler substances by physical means. Okay, so to determine the purity of substances, okay, we have criteria for determining the purity of substances. Okay, now for solids, the criteria for determining the purity of solid is the melting point. Okay, a pure solid has a sharp melting point and a very narrow melting range. We're going to take an example: benzoic acid. A pure benzoic acid has a melting point of 122 degrees C and a melting range of 120 to 122 degrees C. Impurities or contaminants tend to decrease the melting point of this substance. So an impure benzoic acid, I said a pure benzoic acid has a melting point of 122 degrees C and a melting range of 120 degrees to 122 degrees C. An impure benzoic acid has a melting point of 110 degrees C and a melting range of 110 degrees to 118 degrees C. So if you look closely, you'll find out that the presence of impurity in this benzoic acid decreased the melting point from 122 to 110 degrees C. Now for liquids, the criteria is the boiling point and the relative density. Okay, so we're going to use water. Water has a boiling point of 100 degrees C and a boiling range of 99 to 100 degrees C. The presence of impurities in water increase the boiling point. So the boiling point of impure water is 105 and the melting range is 99 to 105. So pure water boils at 100 degrees and has a range of 99 to 100. While impure water has a boiling point of 105 degrees and a range of 99 to 105 degrees C. Now you can be asked a question like this: an organic substance melts at 115 degrees to 122 degrees C. This indicates that the solid is dash: A, pure; B, impure; C, hygroscopic; D, deliquescent. From the range of this melting point, you see that the melting point range is wide. Okay, so it is impure. Impure. If you look closely at the range of melting point for benzoic acid, you see is not wide, it's very narrow, 120 to 122, but this is very wide. Okay, so it indicates that this solid is impure. So we're going to dive into the main topic of today, which is element. Okay, element is a substance which cannot be split into simpler substances by any physical process. Element is divided into three: metals, non-metals, and semi-metals or metalloids. Okay, so metals are elements which ionizes by loss of electron. Okay, examples of metals, we have the sodium, potassium, calcium, magnesium, gold, silver, etc. So they ionize by loss of electron. Okay, so let me take sodium for example. This is sodium. Sodium ionizes by loss of one electron to form a cation. So sodium is a reducing agent because it undergoes oxidation. Okay, when we talk about oxidation and reduction, you get it clearly. So let's take magnesium for example. Magnesium ionizes by loss of two electrons to form a cation, etc. Now, for non-metals are substances that ionizes by gain of electron. Example of non-metals, we have chlorine, we have iodine, we have nitrogen, etc. Okay, so we're going to take the differences between metals and non-metals. We're going to take differences in their physical properties and differences in their chemical properties. For metals, like I said earlier, metals are reducing agents, meaning that they ionize by loss of electron to form cations. Thus, they undergo oxidation. So here we have metals and non-metals. Metals are reducing agents. Okay, sorry, their physical properties. Yes. So physical properties of metals and non-metals. One is that metals, they are malleable, they are ductile, and they are sonorous. When I say malleable, I mean that they can be hammered into tin sheets using a hammer. Ductile means they have the capability of flowing. They can be led through a tin sheet. And sonorous means that they are capable of producing sound. So they are malleable, ductile, and sonorous. Non-metals are not. Okay? Metals, they have great textile strength. They are strong. They are hard. While non-metals, they are brittle and they are soft. Metals, they are good conductors of electricity and heat. Non-metals are not good conductors of electricity and heat, except for graphite. Note, except for graphite. You can be asked the question, which of these non-metal is a good conductor of heat and electricity? Graphite is the only non-metal that is not that is a good conductor of electricity and heat. The rest are not. Okay, so take notes. You can be given an option, you can be given chlorine, graphite, nitrogen, iodine. Which of the following is a good conductor of electricity and heat? The answer is graphite. Okay, now metals are have high boiling points and melting points, while non-metals do not, except for carbon. Carbon is the only non-metal that has a high boiling and melting point. Please note these exceptions and don't interchange them. Graphite is the only non-metal that has good conductor, that is a good conductor for heat and electricity, while carbon is the only non-metal that has high boiling and melting point. Metals, on the other hand, also have high density, high relative density, while non-metals do not. So these are the physical properties of metals and non-metals. Also, metals are not lustrous. That is, metals are lustrous, they glow, they shine, they are radiant. While non-metals, they are not lustrous. Okay, now we've treated the physical properties of metals and non-metals. Now we have the chemical properties of metals and non-metals. So the chemical properties of this metal is that, like I said earlier, it's a reducing agent, while non-metal is an oxidizing agent. Metals, they form as basic oxide with oxygen, basic oxide, while non-metals form acidic oxide with oxygen. Metals, the reactive metals have the tendency to displace hydrogen in acid. So they displace hydrogen in acids, while these ones do not. And finally, metals they form ionic compounds. Metals form ionic compounds, while non-metals form covalent compounds. Okay, so both metals and non-metals can undergo polymorphism or allotrophy. Polymorphism or allotrophy is the occurrence of an element in more than one form, okay, but in the same physical state. I'm going to draw us a table of different elements and their polymorphic form. Okay, so we have elements and their polymorphic form or allotropic form. So we have carbon. Carbon, the allotropic forms of carbon is diamond and graphite. For sulfur, we have rhombic sulfur and monoclinic sulfur. Okay, for tin, we have the white tin and the red tin. Okay, for phosphorus, we also have the white phosphorus and the red phosphorus. Oxygen, we have the dioxygen, which is the normal oxygen, O2, and we have the ozone, which is the trioxygen, O3. Okay, so these are the allotropic forms of different elements. They can ask you the allotropic forms of sulfur. Don't say white sulfur and red sulfur. It's rhombic sulfur and monoclinic sulfur. It always comes out. Okay, so I'm going to stop here today. Thank you very much. Subscribe for more videos. Thank you.